able to finish the material before school break. Does anybody have any questions on the layout of the dates? No? Alright, so then you can go to the first page. So we're going to get started by talking about our simpler figures today, just to get the foundation set. I'm sure you guys have heard of some of these before. And again, all these formulas we're going to be talking about will be provided. It's just how you use them and find the information that you need. That will be sometimes complicated, but not always. So let's start with some vocabulary. So we have a polyhedron. In Unit 8, we talked about polygons, where that was a flat shape like a pentagon or a square or a rectangle. We talked about polygons. A polyhedron is a, why is that such a long line? It is a 3D figure whose surfaces are polygons. So it's in the third dimension, right? It has height, width, and length. So you have that kind of 3D space kind of figure here. And the surfaces, which are the faces of the shape as you're going around, those are polygons. So like this one, for example, has a bunch of rectangles. They used rectangles as the surfaces to make a box. And a box is considered a 3D figure because it has three different dimensions, the length, the width, and the height. Okay? So we're going to be talking about three different things with these formulas, and again, they will be provided for you. But the first one that we're going to be talking about is the lateral area. Now, the definition of the lateral area is the sum of the areas of the faces, but not the base. For bases, if you have more than one base. So the lateral area is basically, if you are thinking about around a shape, you have the area around the shape, but not the top and bottom, is what lateral area is. So if you think about, let me think of an example. Can't really think of an example right now.
Like a Pringles cup?
Yeah, so like a Pringles cup, the wrapper on a Pringles canister thingy, if you take the wrapper off, it's only around the sides, right? It doesn't include the top or the bottom. So that would be a lateral area, just around the sides, okay? Surface area is the sum of the areas of the faces and the bases. Faces and the bases. So the surface area is going to include everything. So it's like when you're wrapping a present. You want everything to be covered. That's the surface area. So the lateral area is just the sides without top, bottom. The surface area is everything. Sides, top, and bottom all combined together. Okay? And then volume is the space inside a 3D figure. The amount of space or the amount of air or whatever that you can contain inside of the figure, that's going to be considered volume. Okay, so those are the formulas we're going to be talking about, and so that's why I am abbreviating surface area with SA, lateral area with LA, and volume with V, in case you guys are confused as we're moving forward. All right, so that's surface area, volume, lateral area, surface area. Is everybody okay with using those abbreviations? Okay, so the first one we're going to talk about is a rectangular prism, otherwise known as a box, if you want to use simpler language. We're going to be talking about a rectangular prism first, and remember, all this will be provided for you. The first formula we're going to talk about for this one is the surface area. This one actually does not have a lateral area. You guys don't need to worry about that. We're only going to be talking about surface area and volume. So the surface area is 2 times length times width plus 2 times length times height plus 2 times width times height. Okay? So what I'm going to do over here, whatever variables I'm using, I'm going to say what they are. So L is the length, W is the width, and H stands for height. And then in parentheses, I'm going to say what their values are. So L represents the length. What is the length of this rectangular prism?
8.
8, okay. What is the width? 3. And what is the height? Okay. So once you identify what all the variables stand for and what their values are, just plug them into the formula. So the surface area for this shape is going to be 2 times the length, which is 8, times the width, which is 3, plus 2 times the length, which is 8, and the height, which is 5, plus 2 times the width, which is 3, and the height, which is 5. So you plug everything into the formula, and then you evaluate. So 2 times 8 times 3 is 48, I think. 2 times 8 times 5 is 80. 2 times 3 times 5 is 30. So you find all those numbers and you add them together, what do you get? 158. Now, in this unit, this is where I'm going to be super picky about you guys writing the units. If you do not include the units, your answer is not correct. So you want to make sure that you guys are really paying attention and getting all that written down. So because this is area, you should have a square there on your unit, and the units be centimeters. So your final answer would be this. Okay? Pretty straightforward. Again, formula, you just have to make sure you know what the length, width, and height are, and then you plug them in. Okay? Same thing for volume, but this time it's length times width times height. So I would do 8 times 3 times 5, which is what?
120.
120. What?
Centimeters cubed.
Yes. Volume has 3 dimensions all being multiplied, so that one would have the cube. Area is going to be squared and volume is cubed when you're writing the units. Alright, sounds pretty straightforward. The box is pretty simple. Pretty clear on that? Okay. The next one we're going to talk about is a triangular prism. So this one is called a rectangular prism because the faces, the sides that we're using, or the bases that we're using to define the shape, were rectangular. This one is a triangular prism because the bases that we're using to define the shape are triangles. Okay, not everything's a triangle because you can see that the faces going around the sides are rectangles, but whatever the bases are, that defines what kind of prism it is. So if the bases were pentagons, that would be a pentagonal prism. So it's based on the base is what you would call this. All right, what do you think H represents in the formulas?
9.
No, what does it stand for? Height. What do you think P stands for? Perimeter of the base. I'll just put that off to the side. It's the perimeter of the base. And what do you think capital B stands for? What about it?
The base area.
Area, yes. You will have a little chart here on your formula sheet. Yeah, you have a little chart on your formula sheet that tells you what most of the abbreviations stand for. So you have capital B is area of the base and P stands for perimeter. That's on here, so in case you forget, that will remind you. But this is all in terms of the base. All right, what is the height? It is 9. What is the perimeter? Can I find the perimeter of one of the bases right now? What would it be? Why?
6 times 2.
That's not how you find the perimeter of a triangle.
That's all the additions of all these sides.
Yeah, the perimeter of a triangle is adding all the sides together, right? Look at the base that actually has numbers on it. Do I have all 3 sides?
Oh.
No. I have one side that's 6, I have the other side that's 8. Do I know what this one is? No. So I can't find the perimeter yet. This is where these kinds of questions will get you. They don't always give you the information up front. So sometimes you have to do a little bit of work off to the side to actually find the information you need before you can plug it in. So if you guys want to, and I do recommend this, you can draw the base off to the side like this. You can focus a little bit more on that. So for the base right now, I know one side is 6 and the other one's 8. How do I find the third side that I need? It's Pythagorean theorem. Do you guys notice how it's a right triangle? They put the little marking there on purpose. So you guys can do Pythagorean theorem. You can do it in your head or write it down.
It's 100.
Okay, so x squared is 100. So what would that third side be? It would be 10. Okay, so just be aware that sometimes when you guys are working with these pictures, they don't give you all the information. Sometimes you have to find it, but it's using stuff that we know already from previous units. So now what would the perimeter be if I know that I have a side that's 6, 8, and 10? Add it all together, those would be
24.
Okay. And then now I need the area of the base. Remember, this is a triangle, so how do you find the area of a triangle?
1/2 base times height.
1/2 base times height. So what is the base and height in our triangle here?
6 and 8.
6 and 8. So I'm going to multiply those and divide by 2. It's the area of a triangle. So 6 times 8 is 48, right? And what is that divided by 2?
24.
Okay. So there you go. So you do, again, you have to use stuff from previous units. You have to remember the Pythagorean theorem. You have to remember what the area of a triangle is, although that is on the formula sheet in case you forget. So now once you find, the work is really here. The work is here, finding the information you need for all of the variables. Plugging them into the formula is easy peasy. The work is over here in the setup, okay? So now the lateral area is going to be the height times the perimeter. So the height we previously found was 9, and the perimeter is 24. So what would I get if I multiply those together? 216 what? Meters squared, because it's an area. Okay, the surface area is going to be height times perimeter plus 2 times the area of the base. Plug everything in. So that would be the 216 plus 48. What is it? 264. Nope, this is still area. If it has area, whether it's lateral area or surface area, it will always be squared for the units. And then the volume is the area of the base times the height. So 24 times 9, which is 216 meters cubed. That one does need the cube. So sometimes when you're working through these, you'll get the same number, but they mean different things because this is an area and this is a volume. Okay? So one more time, the work for these kinds of questions is typically over here in the setup. We have to do some extra work over here, but actually plugging into the formula will be easy peasy once you know all the variables. Okay? Questions on the triangular prism? One thing I want to note before we go on, how do you guys measure your height as a person? How do you measure your height? From where to where represents how tall you are.
From my feet to my head.
Right? From your feet to your head. You could consider as a human, your bases are your feet and your head, right? You have the top and bottom of you. How would you find the height of a prism? Would you go from its feet to its head to measure its height?
Yeah.
So if I knock this on its side, if you take your piece of paper and you turn it sideways, so now it's sideways, would the height change?
No.
No. Does your height change when you're lying down?
No.
Do you measure your height like this now?
No.
You still measure from your feet to your head. So something to be careful with these kinds of pictures is if it's sideways, if it's on its side, the height is still going to be from base to base. It's not always up down. It's from the top of the shape to the bottom of the shape, whether it's vertical or horizontal. It's a very important concept to remember. Okay. All right, the next one we're going to talk about is a cylinder. This one's going to involve pies because it is round. Anything that has a round aspect to it is going to be involving pi because we have circles in here. So what do you guys think radius stands for? What do you think R stands for? Radius. Think. Give it away. What do you think H stands for? Height. Okay, we're going to find both of those. Remember, all of our work is over here in the setup, and then we just plug it in and we're good to go. So what's the radius for this cylinder? And what is the height? Is that a 6?
Yeah.
You're right. It just looks fuzzy on the screen. All right. We got them. And again, if the cylinder was sideways, would the height change?
No.
No, the bases are the circles from the top to the bottom, or from the feet to the head of the shape is the distance from the two bases of the circle, so it's 6. All right, the lateral area is going to be 2 times pi times the radius times the height. Now, you guys must write your answer in terms of pi every single time. I know when we were working with circles last unit, I gave you guys the option to write the decimal version and the in terms of pi version. They almost exclusively use in terms of pi for this unit, so I want you guys to get used to that. Sometimes they'll give decimals, but more often than not, they will be using in terms of pi. So I want you guys to get used to that. So remember, you're just going to multiply these 3 numbers together, 2 times 5 times 6, and then you write the pi symbol. That's in terms of pi, okay? And what would the units be?
Centimeters.
Squared, because this is the lateral area, okay? Surface area is going to be 2 pi radius squared plus 2 pi radius times the height. So over here, what would this become? A 2 pi 5 squared. It's really 2 times 25, right? Or 50 pi. And then didn't we already find this? That's up here, right? It's the same thing as the lateral area. So that was the 60 pi from before. When I add those together, what do I get? 110 pi
Square?
centimeters squared.
Wait, so if you have pi twice, what do you do? Like,
They're like terms, so you just add them.
Okay. No, the pi.
I know, they're like terms, so you
So
add
you
the
don't change
coefficients.
anything about them?
No, it's just like 2x plus x is not 3x squared. 3x. Alright, so this is pi radius squared times height. So this would be 25 times 6. 150 pi centimeters cubed. So again, please make sure you're writing your answer in terms of pi every time, unless the directions specifically say otherwise. Good to go. Alright, questions on the cylinder? Okay. Our next two that we're going to wrap up with today are the sphere and the hemisphere. This one you will not have on the formula sheet. The sphere you will. The hemisphere you will not. So you have to memorize these three kind of deviations from the sphere formulas. You're going to have to memorize those yourself. But for the sphere, again, the only variable we're using is the radius, which in this scenario is 5. The formula for the surface area is 4 times pi times the radius squared. So what would that come out to be? 100 pi with the units.
Centimeters
Squared.
squared.
So that's the surface area. This one doesn't have lateral area because it doesn't have flat edges, right, to get all the way around, so it only has surface area. Then the volume is 4/3 times pi times the radius cubed. This is where it's easy to mess up. This is the only one that involves a cube in it for the formulas that we're learning today. So you guys need to make sure you remember that cube because you're so used to writing squared every time. Alright, so if you have a fraction here, you guys can go ahead and write the number in front of the pi as a decimal as long as it's rounded, or you can write it as a fraction if you want to turn it into a fraction using your calculator. Either way, what would it look like as a decimal if you were to do 4/3 times 225, I believe,
I think it's 166.
to 166.7.
Yeah, that's what
If you do 4 in a fraction, you need to make sure it's in parentheses. When you plug it into the calculator, make sure the 4/3 is in parentheses. Then you multiply that times 5 cubed, not 5 squared, and then you should get 166.7. And then you include the pi to actually write it in terms of pi, and that would be centimeters cubed. So you could also write that as a fraction. I don't have the fraction written down on here, but you can turn the 166.7 back into a fraction before you write the pi, and that would be acceptable as well. Alright, everybody clear on the sphere? Just remember the parentheses are on the fraction so you don't mess up your number in the calculator. Alright, the last one they were responsible for today is the hemisphere, and these you will have to have memorized. This is the only thing you'll have to have memorized in terms of formulas. So again, we have the radius is the only variable we're using. This one does have a lateral area. The sphere did not, this one does. So the lateral area for a hemisphere is 2 pi r squared. 2 pi r squared is the lateral area. That's one of the formulas you need to memorize. So this would be 2 times 25, which is 50. So this would be 50 pi centimeters squared. Okay? Now, this one has a surface area. The surface area for this one is 3 pi r squared. For a sphere, it's 4 pi r squared. For the surface area, it's only 3 pi r squared for a hemisphere. I know that might seem weird because the hemisphere is half of the sphere, so why isn't it 2 pi r squared? Well, that's the lateral area. It kind of switches, and you take the top off of the sphere. Now inside the sphere is showing, so you have to treat it a little bit differently. So the surface area is going to be 3 pi r squared, which is 3 times 25 this time. So again, that's another one you have to memorize. The lateral area is 2 pi r squared. Surface area is 3 pi r squared. Okay? And then our volume, this one should make sense, right? The volume of a full sphere is 4/3. Therefore, half of a sphere should be 2/3 when you're finding that volume. So these ones are a little bit tricky to memorize, right? But this one, you can just remember the volume is half. So you can figure that one out. So this would be 2/3 times pi radius cubed. Don't forget to cube the 5. So what would that one be? This one is a decimal again.
Isn't that 83.3 repeating?
Oops, I put the decimal on. 83.3. You don't have to do the repeating per se, as long as you have at least one decimal that is rounded correctly. Centimeters cubed. Okay? So those 3 you will have to make sure you remember. They are not going to be provided for you on the formula. Alright, any questions on the formulas? Alright, we have a bunch more practice over here. I'll do some, but not all. Actually, what I'm going to do is I'm going to skip to the multiple choice questions down here and talk about those with you guys. And then you guys will go back up to the top of the page and do those extra questions on your own. Okay? So let's talk about these multiple choice questions first. Alright, so actually I'm going to start with number 6 here. This one says that a sphere has a volume of 750 feet cubed, and I'm trying to find the surface area. So, first thing you want to notice is what they're giving you. You use a lot of highlighting and underlining with these kinds of questions, especially if it's a word problem, so get used to that in this unit. They've given us the volume. We are trying to find the surface area. So whatever you're trying to find, can you tell me what do I need to know in order to find the surface area?
Radius.
I need to know the radius. That's the only variable I need to find the surface area of a sphere. Have they given me the radius?
No.
What have they given me?
The volume.
The volume. So how do you think I would use the volume to find the radius, which is what I need? Yes?
You would put in the radius formula and maybe...
The radius formula?
No, not the radius formula, no. You put in the volume formula and that equals 750.
Okay. Yes, we're going to solve backwards. Remember when you guys were missing variables and we had the formula, we solved backwards? So this one, they gave us the answer, but not the information. So we're going to solve backwards, kind of like Jeopardy. We're going to use the volume formula. So if you need to look back, the volume of a sphere is actually now I don't want to make a mistake. Yep, 4/3 pi r cubed. This is our formula for the volume of a sphere, and I know that's equal to 750. What I don't know is r, so I need to solve for that in order to find the surface area. See how I have to do all that reasoning before I can even start the question? Figure out what I know, what I don't know, and how to find that. So that's what I'm going to do here. How would I solve to find this? What would I do first, algebraically? Okay, by doing what? Multiply what?
3.
Okay, you can multiply times 3 to get rid of the fraction. I did it slightly differently, so I'll have to break that up a little bit. Huh?
I multiplied by 3 and then divided by 4.
Yep, you can do that. So you can multiply times 3 and then divide by 4 to get rid of everything. So 750 times 3 and then divided by 4 to get rid of the entire fraction altogether should give you this. Correct?
Mm-hmm.
All right, now what?
Get rid of a cube.
Don't do that yet. We'll talk about that in a second, but don't do that yet. What would I do next?
Divide by pi.
Divide by pi, because you want to get rid of the pi first. So remember, you guys have the pi symbol in your calculator. So you would do that divided by the pi symbol. So that will give you r cubed is equal to 179.05, rounded. Okay, now Ella's question about getting rid of a cube. We've talked about getting rid of squares before. You would just use the square root, right? What do you think you would use to get rid of a cube?
Cube root?
A cube root. Now, if you're not sure where that is in your calculator, there is no button like there is for the square root. If you guys hit the math button, math, and then you go down to option 4, you should see a little cube root symbol. So if you hit math 4, that'll get the cube root to pop up.
I feel like we've used this before.
Yeah. And then you would type in 179.05, so you're taking the cube root of that. You get approximately 5.6. So again, math, if you want to write this down in your notes, so you don't forget, math option 4 That's where you get your cube root. Okay, so I found my radius. Remember, that's what we were after, but ultimately, what was the question asking for? The surface area. So I found the radius. Now what I have to do is plug that into the surface area formula, which is 4 pi r squared. 4 pi r squared. So to find the surface area, now that I have everything I need, 4 pi r squared. So you're going to do 5.6 squared, multiply times 4, and then write that in terms of pi. Give you guys a second.
125.44.
125.4. Just do one decimal for now. Pi what?
Feet.
Feet.
Cube.
Nope.
Square.
Square.
It's not
This
volume.
is surface area.
Only volume is cube.
Correct. Alright. Now let's try these multiple choice questions. So expect to see these kinds of things where you're not given everything. You might have to solve backwards and then forwards. That's back and forth sometimes. Alright, this one says that we have a fish tank in the shape of a rectangular prism. So whenever I see the name of a shape, I like to square that or circle it so I know what shape I'm working with. So we have a rectangular prism, and it has these dimensions. The length is 20, the width is 10, the height is 12. What is the volume of water in the tank when it is 4/5 full? Okay? So I'm just trying to find 4/5 of the volume. Do you guys understand that's what the question's asking? I don't want the entire volume, I just want 4/5 of it. So I'm going to do 4/5 of the volume. Now, who can tell me what the volume would be as a formula? Okay, so it's going to be 4/5 times length times width times height. 4/5 of the volume is what I'm looking for. And did they give me all those?
Yes.
Yeah, so I'm just going to plug them in. So it's 4/5 of the length times the width times the height. So you're going to multiply 20 and 10 and 12 all together, and then multiply that times 4/5. 4/5 times 2400 is what the number inside parentheses would be. And then when you multiply that by 4/5, what do you get? Yep. So we answer choice B. Everybody see how we did that? Yes? Okay. Next one. Which is the closest to the total surface area of a cylinder? There's another name of a shape I like to look for. And then I underline what I'm looking for, so surface area. If it has a radius of 5 inches and a height that is equal to its diameter. So, first of all, this is a cylinder and I'm trying to find its surface area. So can somebody tell me what the formula would be that I'm using here? The surface area of a cylinder. Okay? This is the formula. What two things do I need to know? The radius and the height. Do I know what the radius is? It is 5. The radius is 5. Do I know what the height is? They didn't give it to me as a number. Instead, they told me what its relationship is to the diameter.
It's the same.
The height and the diameter are the same. Do you know what the diameter is?
Yeah.
What is it?
It's 10.
It's 10. The radius was 5, right? If the radius is 5, what's the diameter? 10. And if the height is the same thing as the diameter, that means that the height is also 10. So now you have everything you need. You're just going to plug it in. So 2 times pi times the radius squared plus 2 times pi times the radius times the height. And then you just work it out. Notice how these are not in terms of pi. This is one of those examples where they don't want the answer in terms of pi. So this time you do want to make sure you're multiplying everything together to get your final answer. You can start off by writing it in terms of pi and then multiply it together. As you guys are working, when you write this in terms of pi, you get 150 pi. But again, notice none of the answers are in terms of pi. So all you have to do is now in your calculator do 150 times pi. Write this final answer, type that in your calculator and push enter. And then it'll show you which one of these that it's closest to. So do your work in terms of pi, and then at the very end, if you notice it doesn't look like that, then you can multiply them together at the very end. So then what is 150 pi as a rounded number? Yes, that's choice B. And then the last one I'm going to do with you before you guys do the top section by yourself to practice. This one, again, we have a cylinder. Let's box that shape. We have a cylinder. It has a diameter of 10 and a height 4 times the radius. And I'm looking for the volume. So I highlight what shape it is and I underline what I'm looking for about that shape. Then I'm going to write down the formula. What is the formula for the volume of a cylinder? Pi r squared times the height. Okay. Do I know what the radius is?
Yeah.
Well, they haven't straight up told me what it is, but I can find it. They told me the diameter was 10. So what would the radius be? 5. So from this, I can say that the radius is 5. Really straightforward. This was our first and easiest one, right? Use your formulas using the length, width, and height. Everybody okay with those? Pretty easy, right? Okay. Over here, what are the variables that I need for a cylinder? The radius and the height. Whenever you guys are working with these, it's a really good idea to write down the variables that you need and then write down the numbers, because then you have it all written down and it's easier to use the formula, so I highly recommend doing that. So when you know what variables you're supposed to use, write them down, tell yourself what values they are, and then it'll make it easier. So what's the radius in this example? What's the radius? It's just 1. The 2 is referring to the entire thing, so that's the diameter, so therefore the radius is 1. What's the height? 10. Even though this is on its side, remember that the height of something is from its feet to its head. So the 2 bases, like your bases are your feet and the top of your head. The base for the cylinder is from circle to circle, so the height is 10. So with that information, you just plug into the formulas, and hopefully you got those numbers. Everybody good with the cylinder? Okay, then we have the triangular prism. This one is just like the box, but instead of all the sides or the bases being rectangles, the bases are triangles here. So remember, the variables you need are the height, the perimeter of the base, and the area of the base. What is the height of this? What's the height of this prism? 40. Again, it doesn't have to be the straight up and down. The height is the distance from the bases, the feet to the head. So it's 40 here. What's the perimeter? Can I find the perimeter just based on what I have in the picture right now? What am I missing? This third side of the triangle. Because in order to find the perimeter, you need all 3 sides. So you have to find that side. How do I find it? Pythagorean theorem. So you're going to do 4 squared plus 12 squared equals x squared, or whatever variable you want to use. And then I believe that comes out to 160. When you do Pythagorean theorem. Then when you take the square root of that, this comes out to be something like 12.6. If Pythagorean theorem is a kind of middle step towards the end product, you can turn that into a decimal. Keeping it as a radical when all the other numbers aren't radicals is not going to be helpful for you. So as a kind of middle step, you can write that as a decimal. And so now what would the perimeter be? 0.6. Okay. And then the area of the base is 1/2 base times height. Again, if you forget, the area of a triangle is on your formula sheet, but the area is 1/2 base times height. So you multiply the base and the height, which is 4 and 12. Remember the ones that are perpendicular to each other? Those are the base and height. So if you multiply that and divide by 2, you would get what? 24. So that's all the information. That's really the hardest part of this question, is figuring out that information. Once you have it all, plug them into the formula, and then you're good. Okay? Is everybody okay with that one? Yes? Alright, then our last one here is the sphere and then the hemisphere underneath it. So I didn't draw the hemisphere. I just kind of expect you guys to imagine half of the circle is gone. So for what's the only variable you need for either of those? It's the radius, right? What's the radius in this scenario? 22. So numbers that you get as your final answer will be kind of big because the radius is so big. So for this question, did anybody have any trouble with the sphere stuff? Pretty straightforward, just plugging into the formula. Everybody okay with that? And again, hemisphere, those ones you will have to have memorized. I'm only asking for surface area and volume this time, but you have to make sure you remember those formulas in order to use them. So, and always leave your answer in terms of pi. unless the direction is downwards. Alright, so everybody clear on those? Any questions?